Hello everyone! This video will be on the 2.7 section of the IBAA curriculum. Please pause the video for a second to look at the concepts, content, and formulae for this section. One sentence that summarizes this section is that a quadratic equation and inequality can be solved using the formula or using the x-intercepts. First off, we need to make sure that we properly differentiate a function and an equation. A function is where you have the y value or f of x on the other side. For example, if you have y equals 2x plus 1, or f of x equals 2x plus 1. An equation, there's no y, there's no output. So it should be like something like this. However, because the quadratic shape is still there with the x, we can use the knowledge from the previous section, the different forms and such. And we will exactly do that in this video. Let's start with the quadratic equations. They could be in the form of 0 equals ax squared plus bx plus c, or in factored form or the vertex form. Given a quadratic expression, we can choose either one. There are pros and cons, but let's take the factored form route first. The goal of solving an equation is to find the value of x. Remember that? If we express the equation as a x minus p x minus q equals 0, well, we can simply get rid of a since both sides can be divided by a. Then we're just left with x minus p times x minus q. Remember what the factored form is specialized in? Well, they're specialized in the x-intercepts. And remember what we learned in the 2.4 video? There's one thing to take away from that video. X-intercept usually means the solution of the equation. This is a perfect timing to bring this back. The factored form and p and q are x-intercepts, right? Therefore, that's it. P and Q are the solutions. So easy, right? So easy, I'll say it one more time. In factored form, P and Q are the solutions of the equation. We can write it as x equals P or Q. So why is that? Well, in x minus P times x minus Q equals 0, either x minus P or x minus Q could be 0, it'll make the entire left-hand side 0. Thus, we can conclude that x minus p equals 0 or x minus q equals 0. So then x equals p, x equals q. Let's take an example. First, I'll write the general form. So our first task is to put this into the factored form, right? Let's see. That looks like x plus 4, x minus 3. I know that because positive 4 times negative 3 is negative 12, and then positive 4 plus negative 3 is positive 1. Therefore, I can conclude that x could be a negative 4, or x could be positive 3. So factored form is easy and all. Why don't we use it all the time? Well, two reasons for that. One, factoring is tedious and sometimes you get lazy. Imagine you have something like 6x squared minus 3x minus 30. Would you like to factor that? Well, I know I don't. Another reason is that some polynomials are impossible or very difficult to factor. Let's take x squared plus 15x minus 3 equals 0. This is nearly impossible to factor. It will factor into something like x minus negative 15 plus minus, sorry, not plus minus yet, plus square root of 237 over 2, and then x plus negative 15 minus square root of 237 over 2 equals 0. Would you like to factor it? Well, I know I can't do this. So, what if you encountered an expression that you can't factor? Well, we have this neat formula called the quadratic formula, and you can find it in the formula booklet over here. You should get used to using this formula. They will become extremely handy. How do you use it? Well, just express your equation in general form and take the coefficients and put them into the formula. That's done. Notice that we have a plus and minus in front of the bracket, or in front of the square root, which implies we can have two solutions. Let's take the same example that we worked on. So for x squared plus x minus 12, our a value is 1, b value is 1, and c value is negative 12. So let's put it in. X equals negative b plus minus square root of b squared minus 4ac over 2a. You don't have to remember this. You can just look back into the formula booklet. Now let's plug in all the numbers. Negative b is negative 1 plus minus 1 minus 4 1 and then negative 12 over 2a is 2 equals negative 1 plus minus square root of 1 minus 4 times 1 times negative 12, so negative 48. 1 minus negative 48 is 1 plus 48, which is 49. I know that this is negative 1 plus minus 7 over 2, which means it can either be negative 1 plus 7 over 2 or negative 1 minus 7 over 2, which are 3 or negative 4. You know, same answers as we got from earlier. You can also solve the equation using the vertex form. This requires the isolation of x with the plus minus to care about when we square root both sides. Perhaps you can find this the easiest. Okay, so let's try that. First we need to complete the square to find this in the vertex form. X squared plus x minus 12 equals 0. Well, I know that this is x squared plus x bracket. There's no a value, so we can just do that. And then it'll be x squared plus x, half of x is 1 over 2. So square that, so we can do 1 over 4 minus 1 over 4. Minus 12. Notice that there's no a value, so there's no tax to pay. X squared plus x plus 1 over 4, which is minus 1 over 4 minus 12, which seems like 48 minus 49 over 4 equals 0. And then let's put that x plus 1 over 2. Let's rewrite that. Minus 49 over 4 equals 0. Okay. So you can see, unless it's given as a vertex form, you don't need to do this. It's always easiest if you just use the right method at the given form. Okay. Now let's isolate x here. So I can say that, oh, x plus 1 over 2 squared is now 49 over 4. And then if there was an a value here, I would have divided a on both sides. But there's none, so or it's 1, so that nothing happens. Now we can square root both sides. And remember, we have to put the plus and minus sign here. 49 over 4, which is x plus 1 over 2 equals 1 over a plus and minus. And the square root, it's 7 over 2. Then x is negative 1 over 2 plus minus 7 over 2, which is the same thing as here, right? So we can say that, oh, it's 3 or negative 4. Now, let's look closely at the quadratic formula. We see this weird square root here. And immediately you should remember from previous years how we can break this formula. What do you think? If we put negative numbers under the square root, the formula breaks. What does that mean? It means that the equation will not have real solutions or real roots. The under the square root, b squared minus 4ac, is called discriminant. Okay. And we can do a test called discriminant test to determine the number of roots the equation has. Okay. So first, let's look at the previous example. I know that the discriminant, by the way, I read that as a delta. My discriminant is b squared minus 4ac. And let's try that. Our b value was 1, so it's 1 minus 4, 1, negative 12. So this is 49. 49 is greater than 0. Okay. So if the discriminant is positive, sorry, I got lost there. If the discriminant is positive, then the equation has two real roots, right? As you saw, the roots were 3 or negative 4. What if the discriminant was 0? Let's take x squared plus 2x plus 1 equals 0. Let's do the discriminant test. Our discriminant is b is 2 minus 4, a is 1, c is 1 equals 4 minus 4, which is 0. Okay. If the discriminant is 0, then you can see that the plus and minus, right, of the quadratic formula doesn't matter too much, right? Therefore, the binary property of the solution disappears. Now there's only one real root. Lastly, let's look at 2x squared plus 2x plus 1 equals 0. Discriminant 2 squared minus 4, 2, 1 is 4 minus 8, which is negative 4. Okay. Discriminant is negative 4, so I have to put this into the square root of negative 4. Ring ring! The calculator crashed, the math is broken. If the discriminant is negative, okay, the equation has no real roots. Two distinct real roots and one real root. Now, if you're in HL, you should notice that there are two unreal roots or imaginary roots. Okay, so if you put this into the quadratic formula, it's this one will be something like negative 2 plus minus square root of negative 4 over 4. So then I can rewrite it into negative 2 plus minus 2i over 4, or it'll be negative 1 plus minus I over 2. Am I right here? Yeah. For this section, we're not interested in imaginary roots, so we can just chill down for a bit. Lastly, let's look at the quadratic inequalities. The quadratic inequalities are simpler once you understand the equation and the roots. After you find the roots, we can test some points, right? Discriminant test, and also test for quadratic inequalities. We can test some points by sketching the function version of the equation. Let's take the example and quickly sketch the function. Okay. So let's use the same example that we've been doing so far. The x squared plus x minus 12 equals 0. Let's say we're trying to put it as x squared plus x minus 12 is, let's say, greater than 0. Okay, so we're going to graph this using the GDC. Okay, our familiar GDC. Let's put it x squared plus x minus 12. That's 11, 12. Let's graph it and see what it looks like. Cool. So, now we need to look at the inequality sign. It says that it's x squared plus x minus 12 is greater than 0, right? Then we know that the function is, we're looking for the function that is above the 0 or above the x-axis. Okay? Then we can see that, oh, between or outside of the roots here are the above 0, right? So from here, I can conclude that if x is less than negative 4, or if x is greater than 3, then this inequality holds true. Okay? Because the line here is above x, given this is above. So I know that x has to be less than negative 4, or x is greater than 3. Okay? The less than or greater, or less than or equal to and greater than or equal to depends on the original inequality. Okay? Okay. For example, if this was x squared plus x minus 12 is less than or equal to 0, well, I know the function is below the 0 or below the x-axis between the x-intercepts, right? And it's inclusive, so I can conclude that it's between -4 and 3. Between -4 inclusive and 3. Okay. If there's one root, well, we can see the graph and see if the graph is above or below. Again, it's the same thing. Same applies for the equations without real roots. Sometimes in IB exams, you will get questions that have f of x is greater than g of x. There are two ways to solve this. Okay. You can graphically solve by drawing both graphs and looking for the points that have higher value of x, f of x than g of x. Okay. For example, let's take f of x is x squared plus x minus 12, our usual one. And then g of x is negative x squared minus 2x minus 1. Okay. So I know that f of x, I want to find the value of x where f of x is greater than g of x. Then we can just plot it. Okay, so we have the y I want as f of x. Let's try the g of x. Okay. If you put the negative number, you're going to put this sign, not the minus sign, okay? Negative x squared minus 2x minus 1. Okay, let's graph that. Aha. So, we can see the intersection happens twice. And because we're looking for f of x is greater than g of x, the value is outside the intersection point, so before this intersection point and after this intersection point should be the right solution. And we can do that by pressing the second calculate maximum, intersect number 5. So that's, where are we? There you go, you see the cursor, let's go near there. And then we know that x has to be less than -3.212. X is less than -3.212. And also, let's find the second intersection point. 5. The cursor is about there. Enter, enter, enter. And the second intercept happens at 1.712. So now we can say that, or x is greater than 1.712. Okay. Another way is to solve it analytically by rearranging the inequality as f of x minus g of x is greater than 0. Then the left-hand side becomes, well, x squared plus x minus 12 minus negative x squared minus 2x minus 1 is greater than 0. Thus it becomes 2x squared plus 3x minus 11. Then we can solve this like the inequality question that we have tried just before. Okay. Lastly, let's try the example given in the guide. Over here, example. So let's try to find the possible values of k, which will give two distinct real roots. Okay. So if the equation has two distinct real roots, I know that the discriminant has to be greater than 0, right? So let's take that. Let's just work on the side here. So I know that discriminant is b squared minus 4ac has to be greater than 0. The b is 2, so it's 4. Let's take those steps. B is 2, so b squared is 2 squared minus 4. A was 3k, and c was k. It's because 4 minus, this is 4 times 3k times k, so it's 12k squared is greater than 0. Oh wow, now this is an inequality question. Okay, so we can use the graphical approach. Let's graph that. Let's delete everything beforehand. Let's try 4 minus 12 x squared. Okay, so let's graph that. So we're looking for the function where it's greater than 0, or aka above the x-axis. So I know that has to be between these two intercepts. Okay. So to find the intercept, second calculate, find the 0, 2. And let's press the left bound before the first one. Enter. I know that my left-hand side is negative 5.77. As you can see from the shape, I know this is symmetric over x equals 0. So I know that the second 0 would also be positive 0.577. Okay? So I know that k has to be between those 2 points. Or in other words, k is between negative 0.577 and it's greater than negative 0.577 and less than positive 0.577. Okay, almost there. The last part, for those who want to really excel in the math and the IB math, you might find this process a bit interesting. What I'll do is I'll try to derive the quadratic formula. So feel free to stop the video at any point if you feel like you can do it by yourself at that moment. Okay? So let's start with the general form. Ax squared plus bx plus c equals 0. Okay? So the first thing I'll do is this is a lot of generalization. What I'll do is I'll try to put this into the vertex form in the given situation. Okay? So there are two ways. Let's take the easy route, which we'll do is using the equation of the formula to find the axis of symmetry. From the formula booklet, I know that the axis of symmetry is x equals negative b over 2a. And knowing that this axis of symmetry is the x value of the vertex, I can conclude that, then if I switch this, it becomes a, the same a, and then x minus h value of the which is the x value of the vertex, is x plus b over 2a squared plus k equals 0. I don't know k, so we'll try to find that. How? By putting this x value in place of x. This is a bit tedious. At this point, I want to make everything the same denominator, so I'll put it as a 4a. Now I know that it's 4a b squared minus 2b squared, which is negative b squared, plus 4ac. So I know that my k value is that. Okay. So I can rewrite this as a x plus b over 2a squared plus negative b squared plus 4ac over 4a equals 0. Whew! Okay, so almost there. So so let's try to solve this. Well, we have to isolate x, right? So let's take out all the things that are farthest away. So we can take out the k value that we just found. It'll be negative, so let's just do that now. So now it'll be b squared minus 4ac over 4a. Do you see where this is going now? Right, and then we have to divide everything by a. So x plus b over 2a squared is b squared minus 4ac over 4a squared. And then let's square root it. X plus b over 2a equals, remember, when we're square rooting, we need to include both positive and negative. So plus minus b squared minus 4ac over 4a squared And then let's take the b over 2a on the other side. So x now becomes negative b over 2a plus minus. Well, I know that 4a squared can be square rooted to 2a. Now I can put this together. X equals negative b plus minus square root of b squared minus 4ac over 2a. Thus, we have derived the formula, the quadratic formula to find the value of x in the equation. I hope you enjoyed this video, and try some questions in this section to really master the skills that we have learned. Anyways, I'll see you in the next video. Best wishes.